Welcome to Decoding the Code, the YouTube show for developers. Get ready for your host, Mark Backus.
Hello, I'm Mark, the host of Decoding the Code. Thank you so much for joining. If you like this content, please give it a thumbs up and subscribe to my channel. Thank you very much. Hello and welcome everyone to Decoding the Code. Today with Oliver Jumpertz, we are going to talk about blockchain and cryptocurrencies. He's a software architect in finance and a crypto enthusiast. Hello, Oliver, how are you doing?
Hey Mark, thank you for having me. It's awesome to finally be here. I'm doing awesome. How are you?
I'm doing fine. I'm so happy that we finally got to make this interview, and I'm really happy to have you as a guest here.
Yeah, finally.
So tell us a little bit about your personal experience with blockchain. When did it start? What did you do, and where are you at right now?
Okay, great question. 5 years ago, I started working in finance, so you could say that I know a bit or two about finance itself. And approximately 2 years ago, I finally started to take crypto more seriously, or blockchain technology, just from the viewpoint of an investor. Markets are pretty volatile sometimes, and just through my exposure to investment bankers and banks themselves, it got me pretty curious about the financial system itself. And so I started learning about the fundamentals. And then approximately 1 year ago, I actually started dabbling into blockchain itself as a developer. Started out with Solidity and took a deeper look at Ethereum. And this is how it all started, and built some dApps for myself, interesting projects with banks that didn't turn out to actually be released in the end, but valid experience and interesting stuff that we tried out there. And here I am.
All right, cool. That sounds interesting. Later, I'm going to go a little bit more into that coding on the blockchain or that
Awesome.
kind of stuff. But now I think it's interesting to analyze what's the difference between a blockchain and cryptocurrencies, because I think often people think it's the same thing. What, in short, is the difference?
Yeah, the blockchain is the underlying technology. So basically a decentralized system like BitTorrent, for example, where you share files. The blockchain actually builds on the same fundamentals of a peer-to-peer network.
Okay.
And the cryptocurrency is actually something encoded into the blockchain, either as a native currency of the chain or as tokens, which we can surely talk about later. But that's basically the difference. The one builds upon the other, while blockchains are definitely the underlying infrastructure that actually enable cryptocurrencies themselves.
Okay, so we could say, talking from a developer kind of standpoint, a blockchain is the TCP, and the packages we send over the network are the blocks or the crypto currency contracts in this instance. So we saw now what is blockchain. So it's this is all I know about blockchain. I'm not an expert on this. That's why I invited you. All I know is it's decentralized. It's a chain of things. So let's say if it's like for banking things, you start so you have a link of a lot of information. So Mark receives 10 euros, Mark spends 5 euros, and then to know how many I have, you have to go through all the blockchain, which for me, I think it's a linked list kind of thing, to find out at the end how much money do I have or what's going on. But could you go more a little bit into detail how exactly it is and how my metaphor maybe isn't that correct?
Of course, I think you're already on the right path. A blockchain is indeed a chain of blocks, hence the name, but it's more like transactions. So what we have to decouple here is, blockchain is currently used a lot for financial applications, but it's not only there to store only financial information.
Okay.
So basically you have a distributed database. If you take a look at traditional databases, you have a central server that's maybe scaled horizontally or vertically, but especially the horizontal part is the interesting one. And now apply this to a peer-to-peer network where every client is actually a database instance.
Okay.
And you start to spread the data. And how you do it is with transactions. So whatever happens, whenever you write to the blockchain, you actually broadcast a transaction to the network, and every client can pick it up. And now we have to distinguish between several clients, because every client can store the data, but it mustn't, because there are also light clients that only store a portion of the blockchain. Because in case of Bitcoin or Ethereum, that's few. I think Bitcoin is at around 390, 400 gigabytes for the full chain right now.
Okay.
Ethereum is way larger, because you have not only transactions but also smart contracts, but I'm pretty sure we get to that later. And now you broadcast those transactions, and there are clients actually called miners or validators, depending on the blockchain you're on. And they pick up those transactions, and every now and then they start mining or validating.
Okay.
In the case of Bitcoin and Ethereum right now, it's mining. So they have to solve a problem that's presented to them to actually find a specific hash. And this is where cryptography comes in. It does not only make it more secure, the whole system, it's also used to actually, well, keep the miners busy and to keep the system secure itself. So in the case of Bitcoin, the miners are presented a challenge. You have to calculate this exact hash.
Okay.
And now the protocol says, okay, take all transactions that you possibly can, because the block size is limited. You can't put unlimited amount of data into a block.
Yeah.
There's an upper limit of a few megabytes, which is actually one part of Bitcoin's promise to make it an every people blockchain, because the reasoning is, if the blocks grow too large, people like you and me with average laptops can't actually participate anymore, because the blocks are too large and our disks do not have enough storage capacity.
Oh yeah. Okay.
So as I said, around 400 gigabytes is still doable. If you have a MacBook like I do with only 500 gigabytes of storage, that still is a little too less, not enough, so to say, but it's still doable. So all those transactions are now taken into account, and the miners now look at the previous block. They take the hash, they take all transactions, and this is a pretty simplified form, but just to you on this matter. And now they have one data point they can decide for themselves, which is an integer. This is so-called nonce. And what you now do is you start with 1, and you start to slowly increment this number, and now you try to hit the exact hash.
Okay, so that's a problem you said that needs. So this is where all the fuss is coming about the electricity that Bitcoin is using because of resolving these problems. Is that correct?
Yes, this is part of the overall consensus, because if we take a step back for a second, if you only have a peer-to-peer network, you can't decide who to trust, because everyone could state this is the truth. And with consensus algorithms, which are actually pretty clever, you try to bring the majority, and this is important, the majority of the network to say this is the truth. Because only then you build trust. And from this trust, you can actually do things like finance and basically put your data in public, so to say. And so, yeah, clients can easily verify a block by simply doing the same thing, or a part of the things the miners had to do, because they see this integer, they see all the transactions, they see the previous hash, and everything they only have to do is calculate if what the data they see leads to the hash that is appended to each block. And if it isn't, they know, okay, throw this block away because this is fraudulently.
Okay, so let me see if I get this straight. So, well, I have a few follow-up questions. You said you broadcast those blocks to the blockchain network. How does it work? How do you distribute that? Are there a selection of servers you send it to and they distribute it, or how does it work?
Actually, every client comes with a few IP addresses, so to say, pre-configured.
Okay.
So every client knows, okay, there are at least 5 to 20 nodes I can try to connect to. And now the network starts to exchange addresses. So the initial nodes you connect to can tell you, wait, okay, but there are 150,000 other nodes you could connect to. And this is how you basically build the network. And at some point, so clients don't store all the addresses because you don't need this. The only thing you need is that all clients are in the end somehow connected through other clients.
Okay, great. So let me see if I understood this right. So I publish this information. So I say, okay, I'm creating this new block, but I have to append it to another block. In order to do that, I have to solve the problem of guessing the right hash or whatever. Yeah. And then I can add that information, and I can then again publish to a server or more servers, which will distribute it to everyone so that everyone knows that information. And then that is part of the blockchain. Is that correct?
Yeah.
Very, very simplified.
Yeah, the important thing is that clients do only publish their transactions.
Okay.
So if you now say, I want to send 1 Bitcoin to me, you only publish this transactional information, and mining nodes pick this information up.
Oh, okay.
And
okay.
Now they start, and every 6, well, in case of Bitcoin, it's about 6 blocks per hour. So 1 block every 10 minutes, which is on purpose. And they decide which transactions to include. And then when they are done, they publish their result to the chain. And then all other nodes can verify whether this block is actually valid. And then it's basically handed to the chain. So yeah, as I said, you have to distinguish between multiple clients because not all Bitcoin clients are mining nodes. So to participate, you don't need 50,000 NVIDIA or GTX or whatever it is. you can basically, as a light node or as a normal node, you can participate with everyday hardware.
Okay, so I tell the network, okay, I want to send 1 Bitcoin to Oliver. And then it gets picked up by a miner node, which will then add it to the blockchain for me. Is that what people mean when they talk about smart contracts?
No, smart contracts are basically a whole other thing.
Okay.
You have to say not all blockchains support smart contracts. But most of them do nowadays. But Bitcoin, for example, doesn't, at least on layer 1, which is the blockchain itself. Dogecoin, the same, no smart contracts. But Ethereum, the Binance Smart Chain, Tezos, and whatever you can come up with actually allow smart contracts. But this has nothing to do yet with what we just talked about. It works in the same way, but it's something different.
Okay, so yeah, I think now I have, and also I hope the audience has a vague idea how it works. So you publish your information you want to add to the network. Then there's a miner node that adds it in short terms, and yeah, that's it. So yeah, what are some real world applications for the blockchain apart from cryptocurrencies?
You can basically store anything on a blockchain with some exceptions. As I said, the block size is pretty important. So there are blockchains for everything. There are even blockchain databases right now being actively developed that allow for a lot more data to actually be stored. But basically, you can imagine the blockchain or a blockchain that allows smart contracts, which is important because without smart contracts, there's no other use than to basically exchange some form of currency as a huge edge computing network. This is the analogy I love the most. Smart contracts is basically programming the blockchain. It's code, bytecode, being deployed to the chain in the form of so-called smart contracts.
Okay.
If anyone has ever programmed in object-oriented ways, a contract is basically an object that controls the whole stage of whatever you build And this whatever can really be anything. You could take your Express app, for example, that facilitates your Mongo database and design it and implement it as a smart contract. So you have points in this smart contract that you can call. And those blockchains usually expose APIs to the public. So each node has those APIs. In case of Ethereum, which standardized a lot of things in the blockchain space, that's in JSON RPC API, which allows you to interact with the smart contract as if you were calling it from your own code. So remote procedure calls, that's it.
Cool.
You can store data within this smart contract, which always requires a transaction. So this is where miners come in once again. Deploy the contract. This costs you money because miners actually have to put it onto the chain. And it's basically treated as an account. So everyone has a wallet or can have a wallet, and those wallets have addresses. And smart contracts also have addresses. And this is how you uniquely identify such a contract. And now let's go back to the example of the Express API. You could do the same by simply letting your front end point to a blockchain node and now do RPC calls on this smart contract. So you can store data, you can associate it with at least the wallet address that sent the transaction. This is your identifier, your user, so to say. You can read from it again. This basically costs no money here, and you can basically use this as your backend.
Wow, cool. That sounds cool. But why would I need to put my Node application on blockchain? What advantages does that have for me?
It doesn't always have an advantage, to be honest, but
potentially
a blockchain is decentralized. You have no central entity that controls the data. Even as the creator of a smart contract, you have basically no choice and no way to control how everything behaves. So things one time put onto the chain are there and you can't delete it anymore. So the main argument many people, and I do always bring, is decentralization. If we take Twitter, for example, where we both originate, Twitter controls our data. And Twitter basically also controls our online identity. At least it's my biggest social network, and I think it's yours too. So if they ever decided to delete you, you're gone.
Yeah, that's true.
This is bad because, well, I think Twitter won't do, because they still have an interest in keeping their users, because they are part of the creator economy and basically profit from people like me and you. But they have the chance. And Facebook might even be a better example, because they have a bad reputation, or had a bad reputation in part for their moderation purposes. So if you put this on the blockchain, even as a creator, you can make the promise, well, this is free, this is public. I can't simply delete your identity. I can't delete your posts. I can perhaps control whether you're able to post in the future, but I will never be able to censor anything you published.
Okay.
So this is the first huge part in this.
So I assume there's already attempts to make decentralized social networks with this?
I think a few weeks or a month or two ago, there was a not long-lasting hype on Twitter to go over to BitClout, ITCLOUT, which is basically a decentralized version of Twitter. I think it didn't take off as planned, but yeah, this is one attempt to actually make a decentralized social network that also has something called creator coin associated with your account, that basically allows your followers or users to invest in you.
Oh, cool. On your own coin, so you have your own currency.
You can have your own coin. You can have your Mark coin. I can have my Oliver coin.
Cool. So if someone would say this all sounds interesting, where could I get started coding stuff on the blockchain? Do I have to code my own blockchain? Can I base on something that already exists?
Yeah, well, there are two kinds of blockchain developers, at least in my opinion. You have core development, which is basically creating your own chain and going really deep into the hardware and on a native level, building the peer-to-peer network, integrating cryptography, building the consensus, and so on and so on. But there are so many blockchains that allow for smart contracts nowadays, like Ethereum, Tezos, and many more, that there's also a second breed of coders, basically smart contract developers, who program the blockchain and use existing infrastructure to build their apps. So while the first is definitely something you need a lot of experience for, because let's face it, it's not that trivial to build all these things.
I figured.
Smart contract development is a little easier, so to say. So I think the best entry, if someone's really interested, is to start with smart contract development and use existing infrastructure.
All right. Do you do you happen to have any sort of resources to get started with that? Something maybe you learned with?
Yeah, I actually started learning Solidity, which is the programming language of the Ethereum blockchain, but not only Ethereum, but the Ethereum virtual machine, which is basically a virtual machine that allows you to execute bytecode and that is integrated into many blockchains nowadays. So you don't only learn Solidity to work with Ethereum, but you can work with the Binance Smart Chain and many others.
Oh, cool.
Come with it. That's a huge thing the Ethereum Foundation actually did to open source and let other projects use the foundational work they actually did. So yeah, Solidity is a great choice. It's not the easiest language, but the Ethereum Foundation has a lot of awesome resources on ethereum.org where you can learn, and there are many courses out there. Yeah, and
cool.
I personally think this gives you the largest exposure and opportunity to work on different blockchains. So this is why I always recommend to start out with Solidity. You can still branch out later because there are also blockchains that allow you to work with Python or JavaScript, or at least a flavor of JavaScript.
Oh, that sounds all very interesting. Okay, so Solidity, I will post that link in the notes here. All right. So yeah, so let's move on a little bit more deep into what crypto is. First thing, when I read something like DeFi, DE/FI, what does that mean, and what is it?
Yeah, DeFi actually stands for decentralized finance. And in the end, it's only an umbrella term for a variety of financial applications. Actually use cryptocurrencies or tokens, which are nothing else than smart contracts that conform to a certain standard and are either fungible or non-fungible.
So you talked about tokens and currency. What is the difference between a token and a cryptocurrency?
Yeah, I usually distinguish both by saying that the currency is usually the native currency of the blockchain, which comes with it, which is Bitcoin in case of Bitcoin, Ether in case of Ethereum, BNB in case of the Binance chain, and so on. This is the native currency, which plays an important role because it's the only currency you can pay transaction fees and such with.
Okay.
And tokens are actually only, which is pretty interesting, a standardized way of building smart contracts. They have a certain set of properties or methods associated with them that give them certain properties. So you can distinguish tokens, once again, between fungible tokens. Those are basically like the currency itself. One is as good as the other. And some famous examples for tokens, for fungible tokens, for example, are Tether, USDT, which is a stable coin based or backed by US dollar, or DAI, which is also a stable coin backed by US dollar, and non-fungible tokens, where one is not as good as the other. So you have unique tokens. Yeah, and that's the largest distinction between, at least, let's call them payment vehicles.
Okay, nice. And what is the difference between Bitcoin, Ether, and some other coins like Dogecoin? And what else is hot right now, or not anymore, but maybe coming back. But what is the main difference between like these different currencies?
Well, actually, there is no difference other than their use and their value. In case of Bitcoin, you have, well, basically a currency that on layer 1 comes with nothing else than the ability to exchange it. Then you have Ether, for example, which is also only a currency, but can be used for more use cases like deploying or executing smart contracts. And then you have Dogecoin, which is once again more similar to Bitcoin because it's only a payment vehicle. You can't do anything else with it other than to exchange it or to maybe settle payments with it.
Okay, now that you're talking about like payment vehicles and stuff, I want to ask which cryptocurrencies are nowadays viable for real world payments, and why is that?
Although I love crypto, I think we are currently at the stage where only stable coins, in my opinion, are really the only valid payment vehicles. So a stable coin is basically a coin that is backed by something in the physical world. In the case of Tether, as I talked about it before, or BUSD, which is just Binance's version of a US dollar stable coin, or DAI, their prices don't move. If you have $1, you have one. If you have one coin, you have $1.
Okay.
And there's no intention for the market to move because it's backed by something physical. And most of those coins are audited. So once a month or so, an audit company basically validates and verifies that for all coins that are on the market, there are equally as many goods, dollars or gold with a certain value stored somewhere safe. So
so it's basically a replica of the real world.
Yeah, in the end, it's a replica of the real world, exactly. You take some form of fiat currency and bring it into the crypto world. You take this money off the market, of the physical market, and in exchange, you get something on the digital market. Exactly. But all the other coins like Bitcoin, Dogecoin, and Ether, in my opinion, at the moment, are simply too volatile to be used as a payment vehicle. Because I like Tesla's move to first enable customers to pay with Bitcoin and then withdraw the decision once again. But this is a topic for another session, I think. But there's something valid in it because it's difficult as a user to decide whether the price in such a volatile currency is actually worth being paid. I like to compare this to in-game money. Because this is a strategy many gaming studios came up with. Create some form of currency in-game that is completely untied from fiat currency in such a way that it's hard or difficult for the user to decide what the actual value of this is. Because if 500 coins are worth $3.99 and 600 coins are worth whatever, $4.99, it becomes difficult for the user to anticipate whether this is cheap or expensive. And in the case of Bitcoin or Ethereum or Doge, you always have the risk that what you pay now may be worth 20% a day later, more a day later. So it's risky. And I personally want to pay with volatile coins at the moment because I either miss out, or from the business perspective, you have the other risk. What if the Bitcoin you charge today is worth 20% less tomorrow?
So you lost as a business.
You're always at risk of those coins not paying your actual bills. And this is something that only stable coins can currently guarantee.
Now that you mentioned volatility, I want to ask these questions, which I find interesting. What determines the value of cryptocurrency? How does it work?
Yeah, I think you once again have to distinguish between multiple coins. So it's important to do some research first. In the case of Bitcoin, before layer 2 solutions, which are actually solutions that are put on top on the blockchain, and even Bitcoin has smart contracts nowadays, but not on layer 1. The value was purely based on the assumption of investors that it might be worth more in the future. And it's a scarce resource because the amount of Bitcoin that can totally exist is limited.
Okay.
In the case of Ethereum, which either is not limited, more difficult to actually anticipate the value of the coin. But the chain does something pretty interesting and basically replicates the real world. Because once again, a step back, why is fiat money worth something? Basically, because you have to do your taxes in it. And that's it. If you didn't have to do your taxes in euros or dollars or whatever, what value would this currency have? Especially since nearly no currency on the world is tied to gold or anything else anymore. It's basically just only paper. And Ethereum does basically does the same. The value of the coin does not only come from investors' anticipation that the value will rise, but you need it. Because whenever you do a transaction, you have to pay a fee. Whenever you want to buy something, you have to pay a fee. So there's demand for the currency if you want to work with the chain. And this definitely creates some more value.
Okay.
Which is completely decoupled from supply and demand on the usual currency markets. Because you can exchange it. So you have exchanges and people want to buy and sell there either. This creates some value, of course, but it's also driven by the so-called gas costs of executing smart contracts. Because whenever you do a transaction, it costs you some money. And this creates, and there are other blockchains who basically, especially since a few months where NFTs became so popular, there are many new platforms that actually require you to pay in their native currency. And this also creates some value for the currency, because if you want to participate, you need this currency. This creates demand and there's a supply, and this is how prices form over the course of the time.
Okay, but what would be the cause that, for example, now we are now the 23rd of May 2021. What like this week, like everything dropped like by 50-60%, something like that. What causes something like that to happen?
In this case, China, which actually forbids working with crypto for some of its industry and market, which is pretty bad. And on the other hand, there are at least rumors that banks had to get rid of some risk. So what you have is a simple market movement. It's basically a pretty simple market theory. If more people sell than who want to buy, prices drop. And this is what happened. At least two large events, one of which we know, which is definitely true, and the other one, which is only a rumor, but well be, caused prices to drop. And this is the volatility of cryptocurrencies right now, because institutional investors are usually the market makers. We don't have single entities right now, or at least not enough, who have the buying or selling power to move the markets. So what you basically have are hedge funds, banks going in and moving a few millions or 100 millions each time. And this is what creates market movements. And this is what also happens on the traditional markets. So this is a pretty important thing. In my opinion, the crypto market does not behave any differently than the traditional market.
Just that there's more movement in it.
Yeah, just that there's more movement in it, because the sentiment currently is way higher. The traditional markets have just left a huge bullish phase through a global pandemic that costed millions of jobs, and I don't know how many more companies, but stock prices simply didn't stop rising throughout this time. And what we've now seen is prices dropping because reality hits. Because I think institutional investors anticipated, hey, this pandemic will be over in a year or two, so let's buy. And this is market movement. Many $100 million put into the market actually let prices rise. Then came private investors like you and me, who also thought to themselves, hey, let's buy growth stocks, because you can't easily make 20, 30, 40% a year. And that's it. And now reality hits once again, and the markets also crash. I mean, look at Tesla, flying high, and now pretty low. And each day it loses a few more percent. And what the crypto market is just the same, but with more movement. Because Bitcoin, I think this is also pretty important to understand, because Bitcoin is currently the crypto indicator.
Yeah.
This is, if Bitcoin rises, there's positive sentiment and other coins rise as well. But if Bitcoin drops, you can see the whole market changing directions only because Bitcoin lost a few percent. Let it be 2, 4, 5, or 10, which is pretty normal for this market. And it's a lot of sentiment.
Yeah, I see it in the app I use. When I open it, I see like my favorite or my highlighted currencies, and they all have the same, or more or less the same graph in the row. So it's all like moving pretty much the same. Some are like up, but mostly it's like the same down or the same up. It's crazy.
Yeah.
All right. So if someone anyway says, oh, this sounds like a pretty good idea, I want to invest in crypto now, which maybe is a good idea because everything dropped. So it eventually, hopefully, will rise again. And if it comes to choosing a platform, with which app, with which platform do I exchange or buy, trade crypto? I don't want you to say a specific name, but what can people pay attention to when choosing one of those platforms? Of course, everyone has to do their research, but what are some pointers?
I think the most important rule is do your research. The crypto market is not yet as heavily regulated as the traditional markets are. And many countries are still on the lookout to find their path and how to handle it. So giving general advice would be not a good idea simply because of this. But what I'd say is do some research and find out what does each platform offer, especially for me in my country. This is not only the ease of use and the UX and how easily you can. You should also pay attention to how much does the platform support me with my taxes. Because people love to overlook the fact that in many countries, what you're doing is financial trading, and the state wants us cut, and this costs money. And if you take a platform that doesn't even allow you to get a CSV export of your orders, which is the minimum I'd require to do, it becomes pretty difficult at the end of the year or at the beginning of the new year when you have to do your taxes to actually find out which coin you bought when at which price. Let me give you an example. In Germany, for example, cryptocurrencies are currently not regulated in the same way as stocks are. So it's more treated like art. And if I buy a coin now and keep it for at least a year, it's tax-free for me. But this means that I need to find out which coins did I buy when, and when did I sell them? And do I have to inform my authorities that I indeed made wins with coins that are not tax-free? So this is the most important thing.
Yeah.
And other than that, of course, good usability, but it shouldn't be too easy for you to make your buys. It should be secure enough, because this is also a pretty important thing. Most exchanges offer wallets that are managed by them, and you should always take into account that there have been hacks in the past that cost many people a lot of money. And you should also pay attention to how easy is it to withdraw this money from the exchange and put it into a wallet that's fully under my control.
Okay. All right, those are some nice pointers. I want to go over some myths that I found online about crypto and blockchain, mostly blockchain. And maybe you can help me debunk them, or maybe even not. I have 4 of them. Let's start with the first one. All data put on the blockchain is public. What do you think about that?
Yes, it is. But
it is.
But it's not transparent. And you have to imagine data put on the blockchain is associated with a wallet address. And this wallet address is also nothing else than a hash. it isn't that you have to put your name on it. So there's no wallet out there stating, hey, I'm Mark's wallet. By the way, I live in Luxembourg and here's my address. So it's intransparent as long as you keep your wallet for yourself. You can take a look in any wallet and you can see how many millions or how many only cents there are, but you can't so easily associate it with a name. So all data is public and everyone can look into everyone else's wallet, but you can't simply put a name on it. Well, if you put your wallet address on your website, then I know this is your wallet and I can easily track where payments go to. But other than this, it's pretty public, but intransparent.
Okay, so if I say, oh yeah, please pay me some Bitcoins for whatever reason, and I give them my address so they could see how many money went and came from that account. Okay.
Yeah. This is perfectly possible because the data itself is not encrypted. But for other use cases, and this is important, no one stops you from, if you use the blockchain as a regular database and put other data on it, no one stops you from encrypting it. So this is all perfectly fine. But other than this, the myth is somehow true. All data is public.
Okay. Another one that is also a little bit with the actuality, where Elon Musk said he won't accept Bitcoins anymore for Tesla because it's too bad for the environment. So the myth is blockchains are costly and inefficient.
Yes and no. The energy consumption, and we talked about this previously and before, usually comes from the consensus algorithms or protocols that are used. In case of Bitcoin, it was an explicit decision to use a proof of work, which is the algorithm that costs so much energy. But there are other consensus mechanisms out there that actually cost only a fraction of what Bitcoin or Ethereum currently use, because Ethereum is currently also on proof of work, but they are in the process of migrating over to proof of stake, which actually doesn't require any advanced graphics cards. This is another system where users or participants are randomly chosen based on the amount of tokens they have locked.
Okay, does this make it less secure?
No, this is also pretty important. No, that's the thing. It's still secure up to a certain extent. This is important. Up to a certain extent, because no blockchain is 100% safe.
Yeah, which takes me to the third myth. Blockchain is immutable and unhackable, which plays right into your comment.
Yeah, immutable, perfectly fine, because that's it. Not all blockchains, because there are even some experience nowadays working with mutable chains and exploring how we could use them. But other than this, in order to understand how secure a blockchain is, you have to understand consensus. And consensus is like a vote. It's always the majority. So, for example, if some entity, be it a state, a criminal organization, or whatever, managed to amass 50.001, so a majority of mining nodes in blockchain on the Bitcoin network, they'd be able to overtake it and rewrite their history.
Okay.
The thing is, this is why Bitcoin explicitly chose, for example, to only mine 6 blocks per hour. This is so cost intensive and compute intensive that it's highly unlikely that some entity is able to build up such massive computing power without us noticing, because we can track which miners mine which blocks at which time. And if someone one day started a data center amassing miners and graphics cards and computing power, we would notice. Okay. And in case of proof of stake or other consensus mechanisms, there are always some other mechanisms in place that ensure that you can't easily overtake the network. Because for proof of stake, which is solely based on the general idea is the larger the stake you hold and lock away, the more often you'll get chosen to validate a block. But there are other mechanisms also put into it, and which the Ethereum Foundation, for example, modifies the algorithm with to ensure that even if you put all money of the world inside it, you wouldn't be the only validator. So this is one of the most crucial things and parts of the software of a blockchain, where the creators and maintainers put a lot of effort into it to ensure that it's not that easy, but it's never impossible.
Never impossible, yeah. Yeah, that's with everything, right? You think like, oh yeah, platforms like Facebook, they must have like the best security and are unhackable. But then again, you see in the news 150 million accounts hacked and so on.
Yeah.
All right, let's come to the last myth. Enterprise businesses are not adopting blockchain.
Oh, many currently do. But we have to put this into perspective. The industry we are working in is currently still in the process of migrating to the cloud. So blockchain endeavors are not that often, and are usually not that reported as publicly as, hey, wow, this large organization is now fully on AWS or Google Cloud or Microsoft Azure. So enterprises are adopting blockchain. It's usually not as publicly visible. And I, for example, know that all major European banks and even the largest in the US are currently working hard on financial products based on the blockchain. And I also know that IBM currently does a lot to ensure that their customers in their consulting business get on the IBM blockchain. So a lot of experimentation, finding out what can this technology bring other than DeFi. And I think that we will see a few prominent use cases within the next 2 to 3 years, because enterprises move slow and it still takes some time, but it's far from the point where no enterprise has any interest in trying this out, at least.
All right. So yeah, I think I asked all the questions I wanted to ask. Do you have maybe something you want to, some advice maybe you want to give people who want to work with the blockchain, maybe some people who want to invest in crypto, some word of advice from you, Oliver?
Yeah, regarding investment, definitely research more. It's so intriguing to go after coins that do a few $1,000% in a day plus. But you at the same time can also drop a few $1,000% in a day. So it's really important. Start with a stable coin, try to get into it, and don't get greedy. This is pretty important because you can get greedy pretty easily when you see all those gains that you could possibly make, but usually they are destroyed within a few seconds as well. Yeah. So if you're a newbie, you should definitely research a lot. And as an aspiring blockchain developer, I'd say get to know the basics, try to find out how this all works, and then slowly try to get into smart contract development. And I can only recommend to start with Solidity because it's so prominent right now. It doesn't need to be the language you'll end up working in at some point, but I definitely use the wide array of resources that you can find online for Solidity to get yourself comfortable with working with it and build a lot of projects. You can easily spin up a test net on your local network and simply try out how this all works. And you should definitely take your time. Yeah, and if you work consistently enough, you have a good chance at actually getting into the industry, because there's a crazy amount of demand for blockchain developers right now that is even crazier than the overall demand for software engineers.
No.
There are periods I have to actually disable all LinkedIn messages because I get around 200 to 500 messages per day with recruiters or companies asking whether I can lead them to more Solidity developers or whether I'm interested myself. It's just crazy.
Whoa, 200 messages a day. All right.
Yeah, and there's a lot of money to be made, but take your time. This is crucial. Especially Solidity is a language that needs to be optimized, especially with the current state of the network of Ethereum, which is overloaded. And yeah, although there's such a crazy demand, many companies look for more senior developers. simply for the very reason that optimized Solidity code can save you a few 100 millions a year. So definitely do your homework, take your time, perhaps start out as a front-end engineer, because this is way easier to get into. You only need the skills you already have as a web developer. Add an interface library like Web3.js or Others.js, and try to interface with existing contracts, for example. This could be a great entry to get into the industry, because you don't need to be an expert at Solidity, and you can build that knowledge and skills up over time.
Thank you so much, Oliver, for your time and your answers. And I hope to see you around. Bye-bye, Oliver.
Bye-bye. Thank you so much.
Oh, you're still here. Thank you very much for watching the video till the end. If you like this content, subscribe to my channel and give this video a thumbs up. Please and thank you.
Thank you for watching Decoding the Code. A new episode will be available every week. So don't forget to tune in next Monday. For past episodes, check out the website, decoding.show.